Hello, so I already have a video about this problem on my channel that is more specifically a, a brute force solution. This one is going to be the optimized solution, so I recommend that you look at the brute force one first. So again, this is our problem. We're working with the array method that returns the pivot index of this array. We define the pivot index as an index where the sum of all the numbers to the left of the index is equal to the sum of the numbers to the right of the index, right? So the sum of the numbers to the left of index 3 is equal to the sum of the numbers to the sum of numbers to the right of index 3. Sorry, it's just like a little English typo I think they made. Also, 3 is the first index where this occurs, right? So 0, 1, 2, 3, right? So this index, right? This is our pivot in this example, right? So this is P for pivot, right? So this array is divided into 3 parts, basically, right? We have our, let me type it out right here. Left sum. Can I make it bigger? Oh, I did not know that. I can make it bigger. That's so awesome. So that's our left sum, right? And can I move this? I'll just make it a little bit smaller. Cool. So this is our left sum. And then our array also has a right sum, right? Right sum. So we're, okay, cool. This array has 3 parts. It has a left sum, a pivot, and a right sum, right? So it's like, there's another way of thinking about this, right? So if our array is divided into 3 parts, and let's say we're going from left to right, right? How can we like always know what our right sum is and our left sum, right? Let's say like we're like working at our very first index right here, index 0. The right sum is everything in this direction, right? And then our pivot would be this number, right? Because there's nothing to the left, right? So our left sum here is 0. So in this example right here, our left sum is 0. And our right sum is 7 plus 3 plus 6 plus 5 plus 6, 17, 20, 27. So here our right sum is 27, and our left sum is 0, and our pivot is equal to 1, right? All right, okay, that's pretty like interesting to know. Now, how else can we think about this right here, right? So it's also possible, right, that then we have our pivot right here. So what's to the right here, right? Our right sum is equal to 11, and our left sum, right? Should draw the left sum like this because it's going in this direction. Our left sum is equal to 11, right? And then what happens? So basically, we have a left sum and a right sum, right? So what happens is we want to traverse the array from left to right. And as we're traversing the array, we want to keep adding numbers to our left sum, right? And so for example, I'll just go back to the example before, I think it'll be clear. If I'm working with the number 1, my right sum is 27, right? 7 plus 3 plus 6 plus 5 plus 6. If I go here, then my right sum, right, then this is my pivot, and then this is my left sum. And now my right sum is 3 plus 6 plus 5 plus 6, 11, 9, 20, right? 20. And then this right here is, the left sum is 1. So how do I know it's 20? Well, I can say 3 plus 6 plus 5 plus 6, but how is my program like gonna know that? Like, how's my program gonna know like, oh, the right sum is 3 plus 6 plus 5 plus 6? Well, what we can do actually, what we can do is we can just find the total sum of this entire array, right? Which is equal to 1 plus 7 plus 3 plus 6 plus 5 plus 6. And that's equal to 28, right? 8, 11, 8, 11, 17, 22, 28. So that right there is equal to 28, right? So basically what this is telling us is when our left sum, right, is equal to our right sum, right? So how can we think about this like mathematically in order to like actually divide this properly? Well, we can come up with different formulas, right? So what's our right sum equal to? Our right sum is equal to our total sum minus our left sum minus the value at p, right? Nums of p. And then what's our left sum equal? I can't believe I just got deleted. All right, so total sum, you already saw before, is equal to 28. And then we have our right sum, which is equal to our total sum minus the left sum minus p, right? Because what is the right sum? The right sum is everything that is not in the left sum or the pivot, right? Because if we have like, if you have like 3/3 a whole, right? You divide that 3/3 into 2/3. What is the remain? What's that last 1/3? The 1/3 is what remains, right? So, well, in this case, we have our 2/3, and now we're looking for our 1/3, right? So it's basically a simple formula, right? So we can also think of our total sum equal to left sum plus nums of p plus right sum. This is like our original formula from which we get everything else. And then we also have left sum is equal to total sum minus right sum minus p, right? So that's like one way to think about it. But we don't really need this because like this is good, cool, but we don't really need this because we're going to be advancing from left to right, because we will be advancing from left to right. And then that's how we're going to keep continuously adding on to our left sum and adding on to our pivot. All right, so let's try coding that out. So where would I start? So the first thing I would do is I would say left sum is equal to 0, right? Because we have a left sum equal to 0. Actually, the first, well, that's fine. But then I could also say for I in, or I can say for num in nums. 1 second. Total sum is equal to 0. So we have for num in nums. We're going to say total sum plus equals num, right? So now you print total sum, and we're going to get 28, right? So now what we're going to do, we're going to say our left sum is equal to 0. So we're going to say for I in range the length of nums, right? So what did I say? Remember, when we start off, as I said before, there's nothing to the left. So this remains 0, right? But do we know our left sum? Yes, we do, because we declared it already. It's 0. So we're not going to do anything to that. Do we know our right sum, right? Well, this right here is our first index. So we're traversing. We're treating this as a pivot, right? Because then when we increment right here, right? So right here, there's nothing to the left, right? We have no left sum, right? When you're at index 0, you have no left sum, right? So our index is our pivot. I mean, so I, in this case, our iterator, or traversing the radius through with, is our pivot. Now, if I is here, right? Well, I'm calling it P, let me just call it I. I'll just call it P. So if our like I value in the, I'll call it I. So if I, right, is here, this is like our pivot, right? Then our pivot index, then like this right here, now we have a left sum, now we have a right sum, right? But when we start off initially, right, we have I, and then this, all of this right here is our right sum, right? So is 0, our left sum, equal to our right sum? That's our question. So we're going to say, I need to define right sum as well, do I? So I need to say, yeah, see, if left sum is equal to right sum, then we're going to return I, right? but I also need to first define my right sum. My right sum is equal to our total sum minus our left sum minus nums of I, which is our pivot, right? Because that's our formula from before. Total sum minus left sum minus P. In this case, it's 28 minus 0. There's nothing to the left of the first index minus P, which is 1. So our right sum is 27, right? Because at the very beginning, all of this right here is equal to 27, right? Because it's 28 minus 1. So then return I. So then if left sum is equal to right sum, I think that's it. Let me see, return -1. I think this should be good. Okay, so it says output is -1 and expected 3. Oh, I know what the problem is now. We have to add 2 every time we check, right? So here at our first index, right? Throws back this example a bit, right? Our first index, right? When I is 0, right? We check to the left. Okay, left sum is equal to 0, right? What's right sum? Is left sum equal to right sum? No, it's not. So what are we going to do? Well, left sum plus equals nums of I, right? This pivot value right here gets added onto our left sum, right? So then left sum plus equals 1, right? So right there, we're going to add 1. And then what's going to happen, right? Then the I is going to go right here, right? And then we have 1. No, I is, yeah, so we're adding 1 to I, right? And then here we're going to add I is going to 7. And then we're going to have our left sum right there. But at first it's 0, right? So first it's 0, right? Then it's 1. Then it's going to be 7. We're going to keep adding on every single time. So now that should be good. Yes. And I just want to make sure that that's like clear, because it's a little bit confusing, right? Because the first time around, just remember, there is no left sum, right? So left sum is equal to 0, right? So we add 1, right? Now I becomes this right here, right? So then we check, is left sum equal to right sum, right? No. Now we're going to add 7, right? And then that makes sense, right? Because then this right here is 8. And then here, we're going to move I again, right? We're going to say, is our left sum equal to our right sum, right? So is our left sum equal to our right sum? Is 8 plus 3, which is 11, right? So is 11 equal to the right sum, right? Which is 28 minus 11 minus 6, right? So 11 is equal to 11, and that's how you get it. Yeah, so that one takes a little bit thinking about, but I know you got it. And